And this is a bit a complicated slide, but what I want to say here in this slide is that we have different types of ion flows, and mainly at Venus we have ion flows of hydrogen ions and oxygen ions. And hydrogen and oxygen are water, so you get 2 hydrogen and for every oxygen, and then you know that water is escaping from the planet. This is what we see from Venus. We see exactly these 2 hydrogen ions for every oxygen ion. And so we can say that currently water is escaping from Venus, but how much is escaping? And this is where this plot comes into play. So you can see different plots. You see Venus, and you see the sun is to the right. So this is behind Venus. And different colors here, just to simplify it. If it's a red color, it means that ions are flowing away from Venus. And if it's a blue color, you can see that ions are going back towards Venus. And this is a very special finding. It's very interesting. You can see it in my the cover of my thesis. You have ions escaping, and then you have some returning. And if you have some ions returning to the planet, you will have less ions in total that escapes from the planet. And this has consequences for how much water is in the end leaving the planet, and in this way making the planet dry or not. And so what we did is that we used this relationship between the escape of these ions from the planet, the escape of atmospheric constituents, and we relate it to the solar winds that I talked about before, this stream of particles emitted from the sun. Because there is a strong relationship between these two, how much is escaping and how strong the solar wind is. Using this relationship and using also how solar wind evolves in time, we can see how much of the water presumably has escaped over the past, say, 4 billion years of Venus. This is a very simplified way of looking at it, but you can get an idea of how important this way of evolving the planet is. And so you have here current time to the right in this plot, and then you move backwards in time to the left. And then you can see the evolution of different parameters of the solar wind. And you can see how the ion escape increases with time. And then you can see that we have more and more accumulated mass loss. Assuming that all of this mass loss is water, you can get some numbers. And then you can crunch these numbers a bit to understand what it means. And in the end, this means that the amount of water that has been lost from the planet Venus through space is equivalent to spreading, if you spread all of this water over the entire planet of Venus, you get about 0.5 meter of water. And when you consider how much water Venus should have had in its early history, it should have been about maybe hundreds of meters thick ocean. And so of these 100 meters of water on the planet of Venus, about 0.5 meter of this has been lost through escape to space in the past, maybe 4 billion years. So that means that a very small part of it has been lost to space in this form. And this has big consequences. This was very surprising when we found it. And this result has had bigger impacts on how we look at the planet Venus and what type of research we do. So maybe more of this water has been collected on the surface and is now located inside of the planet. Maybe there was a different type of escape than what we have looked at here. Or maybe Venus didn't have as much water as we thought in the beginning of its history. And that's a very interesting result. And it makes Venus very interesting. It has these complicated things that we still don't really understand. Okay, so that was a little bit about some of my research. And I wanted to end a bit about some personal lessons that I've learned so far that I think maybe some people can bring with them when they consider what to do in the future. One of the things is definitely never to be afraid to ask for questions, ask for opportunities. The worst thing that happens is that you get a no. And I learned this really during my studies. I asked for research opportunities. I've asked for going to different master thesis programs, etc. And I thought I would never get it. There's no idea like, there's no purpose in me sending these emails, but it turned out to be very important and actually promoting myself. The second one is that even a very, very shy person that barely can speak to anyone can, from a very small place like Vashos, can really reach their dreams or reach what they want in life, to work with the space that I was standing and looking at during my childhood. And of course, something that I want everyone to take with them is that Venus is a very exciting planet, and there's still so much that we don't understand. And maybe Venus is actually the next planet we should go to with humans, but that we can talk more about another time. And with that, I would like to thank you for listening.
Thank you so much, Moa. That was amazing. Thank you. Loved it. What an exciting journey, and it's only really just begun. I mean, I'm going to open up the floor now for questions. We've got more people joining, which is great. Would anyone like to start? So in terms of your research, now, Moa, you said you were a little bit more focused on Mars. Did I understand that correct?
Yeah.
But if I can go back to Venus, I mean, what would you like? What's next for you? What would you like to explore and find out further about Venus, if you could go back and focus on that planet?
So if we're talking about Venus, one thing that's very exciting, I think, is, so if you look at this illustration, it's very sort of simple, and you have this simple flow, and then it sort of drapes around the planet like this. And Venus is thought to be a very simple planet, because it doesn't have magnetic fields, and Mars, for example, has crustal fields. But even with this simple case that we think we should understand, we don't understand. There's so many things that we don't understand. Why are these ions returning to the planet, for example? And so I think I'm trying to promote that we should send a new mission to Venus to really study this in further details.
Excellent. Could it be the case of a Swedish mission, do you think?
That could be really cool. I think Sweden has the opportunity to send their own missions, but I don't know if they're happy to do it. Usually we do it through the European Space Agency.
Yeah, exactly. What is NASA? Are they doing any work on Venus at the moment?
They have actually 2 missions currently developed to go to Venus, but neither of them are going to look into the things that I am interested in, the plasma environment. They're going more further into the structure of the surface or the atmosphere. So that's very exciting, and it's going to contribute to these questions. But
do they know of your work?
Yeah, they do. And they are excited about the results, because it means that maybe the surface interaction with the atmosphere is more important than was previously thought.
Oh, wow. This is so exciting. We want to hear more about this. Thank you.